So here is the fourth and final example for chapter 7. This is once again 7.5. This is our final example. But this one's going to be will work with your mind for a little bit also, just like the other ones did. So this one, it says we're going to solve 2 sine theta plus 1 greater than 0. And you're like, whoa, 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 whoa. Why'd you put the inequalities in here? We've just been dealing with equations. Why putting inequalities into this? We never dealt with inequalities before, so that's what we're going to do with it now. But just like we did before with inequalities and how we solve those out, that's how we will solve these out again. And just like we would solve like a regular equation, we solve the trigonometric equations. That's the kind of same thing we're doing with inequalities. So with this one, it says solve 2 sine theta plus 1 is greater than 0 for all values of theta between 0 and 2 pi. So this one limits our values down so that we don't have as much as we possibly could for every single value there. So this one just gives us the interval between 0 and 2 pi. All right, so let's solve this out and find out what sine theta would equal or be greater than. All right, so let's go ahead and solve this out. And just like regular inequality equations, we can solve this out by setting it equal to 0 and then putting inequality back in later on. So we're going to do 2 sine theta plus 1 equals 0. We're going to solve this for sine theta. So we'll add subtract 1. So that'll give us 2 sine theta equals a negative 1. We're going to divide by 2. We get sine theta would equal a negative 1/2. Alright, so solving it out to get sine theta by itself, we get sine theta equals negative 1/2. Alright, so with this one, we're going to go and put it back to the inequality that we originally had. And this is where the tricky part comes in. Not really tricky, but makes you think and makes you go back to the table we've done, the chart we've talked about. Or the unit circle, as Miss Orban's class has done already, and we did it too. But what we need to find are where are all the values for this function, the sine function, where we are greater than negative 1/2. So that means that it's either like negative 0.1 or negative 2 something or negative just a negative number or a positive number. So if we were to look at our sine functions here, we would know, okay, and before we go into this, we'll look at all these quick trick to remember where for the unit circle where they will all be positive, where sine will be negative, or where sine will be positive, and all the good stuff. There's a quote or saying, all students take calculus. If you remember that saying, all students take calculus, all students take calculus, all students take calculus, take calculus, all students take calculus. If you remember that, you can figure out where will all the positive answers be. If you look at this first one, all, in quadrant 1, if you remember, sine, cosine, and tangent are all positive. There's no negatives in that one at all, because it's all the first quadrant. It's all positive. If you look at the second quadrant, if you look at students there, that's the same beginning letter as sine. So that means that the sine function in this second quadrant will be positive. If you look down here for this third quadrant, t, same thing as the first letter in tangent. So that means that tangent will be all positive here, and all the other ones will be negatives. And then for this one, c has the same first letter as cosine. So cosine will be all positives in this fourth quadrant. So all students take calculus, so all will be positive here, sine will be positive, tangent will be positive here, and cosine will be positive there. But we're dealing with just sine itself. We're looking at where that's going to be positive, be greater than negative 1/2, excuse me. So we know, okay, here sign is positive, here sign is positive, here sign is negative, that's negative. All right, so we have to kind of figure out where this interval will be that is going to be greater than negative 1/2. Now, if you look in this third quadrant here, at a point it's negative 1/2, and then it starts getting bigger negative numbers down as it goes this way, right? If you look back at your chart, remember the values. So at this point, where in quadrant 3 would we have a negative 1/2? Looking at radian measurements, because it's between 0 and 2 pi. Think about it, think about it. And if you said 7 pi over 6, you're right, because you remember that off the top of your head. Not looking back at your chart at all. All right, so then this equals negative 1/2 for sine, and everything else starts getting bigger negative numbers. Bigger and bigger negative numbers. So if that happens, we got to find out where the negative 1/2 would be again, so that we can start going back to positive numbers here, or going back towards the positive numbers. And that would be somewhere around in here, which remember that is by the top of your head. And probably not, because you guys either haven't studied or didn't remember to study, or it's like, there's a lot of stuff in this chart, Mr. Hall. I gotta remember all this stuff. I gotta remember it. You had time to remember it already, so remember this information. It's 11 pi over 6. That's where there's going to be a negative 1/2 again. So if we look at, okay, we know sine's all positive up here, and this is negative 1/2, then all negatives here. So that means from, pretty much from, you can start from, let's say from here, going all the way up, around there. All these would be all where sine would be greater than negative 1/2. So if we were going to write this out, we need to write this so that it works going counterclockwise. So we would need to start at 0. We'll say from 0 between 0 and 7 pi over 6. And with this one, at 0 it's going to be greater than negative 1/2. But at 7 pi over 6, it is negative 1/2, so we can't put an equal to sign there. So we'll say first off, that's not pi, should be a theta in the middle. So we'll say first off, theta is going to be between 0 equaling 0 and 7 pi over 2, but not equaling that. But then also we would say it's going to be 11 pi over 6. Not equaling that, because at 11 pi over 6 it is negative 1/2, all the way to 2 pi. So those will be our intervals of what we're looking for, where sine theta would be greater than negative 1/2. Right, now in class we will go ahead back over this again to make sure everybody understands and sees what's going on. But this is it. This is the end of it. So we will get more practice here. Let's see. I'm going to have you try this one. I didn't look at it yet, but I haven't looked at it this year. But yeah, let's try this one. And it's not up here. Let's go back to it and put it up. Let's try this one for a practice problem. See what you get. So 2 sine theta is going to be plus 1, just like the last one. This one is going to be less than 0. And it's going to be, once again, for theta being between 0 and 2 pi. We're going to check that out and see how it happens.
Hey buddy, how long you gonna be here?